With the advent of the common rail diesel, the question gets asked, why do I need to change my diesel injectors? Well, right here, we've not only got Matt the expert, but we've also got some worn out injectors that we're going to have a look at and show you why. So Matt, why do we need to change them?
There's actually a couple of parts to it. I mean, we're fortunate enough we get through a couple of hundred every week, so we get to see a lot of the failure modes, and over a couple of years we've built up a pretty hefty database. There's two parts to it. Firstly, we need to understand how the injectors work, and if we look at an older injection system, even like a 1HD for example, they run at like 900 to 1000 bar, they injected once per stroke. The new common rails can inject anything up to 2200 bar and 4 or 5 times the stroke. A couple of pilots, the main, a couple of afters. So they physically do a hell of a lot more work.
Right, as simple as that.
Absolutely.
So this injector here, that's just come out of a vehicle and been stripped down. When you look at this, what sort of issues are you seeing here?
A lot of the time the failures that we see are either wear related, just purely miles, or accelerated wear due to some sort of physical contamination or water contamination.
Okay, so water, well, I guess water could then cause rust in the component?
Which I think is actually probably more the issue. It's not the fact that the water got in there. The water can get in there and pass through. It's more the fact that the water got in there and caused, generally speaking, the rail or stagnant parts of the injector to rust out. Those rust particles break off and then go through the injector.
Right. Now, these injectors, I think we've all understand that they're made to very exacting tolerances. Yeah. Are these injectors more exact than the older style?
By a massive margin.
Really?
Oh yeah. So, for example, some of the older tolerances, you might be able to run 10, 12 micron tolerances between, say, plunger, piston and barrel. We're now running that down to like 1.3, 1.5.
Wow. Now, micron's a thousandth of a millimetre.
Yeah.
That is small. So now this nozzle here, when you look at that, what are some of the things that you're seeing there that will affect the running and operation of the vehicle?
So there's actually some pretty interesting stuff. Now, if we look sort of back 10, 15, 20 years ago, you had a 18Z or a TD42, you would be recommended to get your injectors changed every 100,000 kilometers to have optimal performance. And that was because the nozzle itself would wear. Even the same with a 1HD or whatever the case may be, the nozzles themselves would actually blow out. Now we're talking about higher injection pressures with much smaller orifice holes. You would kind of think that it would be logical that these would be the wear point.
Absolutely.
But in fact, technology, mainly metallurgical and heat treat, has actually moved to a point where these are now remarkably stable. It's not the part that wears. Now, we can flow rate these between new ones and old ones and make inferences, but in actual fact, so we talk about a micron being a thousandth of a millimetre. The actual hole diameter in these things is only about 145 to 150 microns, depending on the part number.
That is ridiculously small.
They're remarkably small, and when you actually see them, they're so accurately cut, like it's quite impressive. But what we are seeing is it's the same type of failure mode that we're seeing in the rest of the injector, where we're seeing the physical contamination or lack of lubricity. It's a bit hard for us to tell. It's kind of like being in the morgue. We can see the hole in the head. We don't know who shot the bullet, but we can see the scoring and the seizure-related marks in all of the moving components. So the actual nozzle needle is the bit that actually cops that the worst, because when the fuel comes in, it comes down and actually has to travel up past this part first. So generally speaking, this is where you will see a lot of the contaminated related evidence. Not so much failures, because this actually runs a slightly bigger clearance than a control piston. We'll get to that in a minute, but evidence of contamination is pretty clear here.
Wow. What's this long sticky thing here, mate? Expert term.
This, we either call it a spindle or a control piston. Now, the way the injector works, we have a solenoid on the top which actuates an armature which opens and closes a valve. So we call that the electrical actuation circuit, then we have the valve actuates a hydraulic circuit. So this and the nozzle needle in the injector literally sit on top of one another and in effect move as a unit. This control piston failure and the marks that we see on here, and more so the extent of the marks, like these seizure related marks are pretty well top to bottom. They're pretty extensive, and when you go to Europe, you just don't see that failure.
So is that because of the quality of fuel we have in Australia?
I'm hesitant to say yes, but I think it's entirely relevant. Yeah.
Well, certainly I guess it comes back to that moisture getting in the fuel.
Yep.
Through whatever means, condensation in tanks,
Yep.
whether it be the Bowser tanks or the vehicle tanks,
Yep.
and then rust,
Yep.
and so on.
And there is a considerable difference in fuel quality too between what we would call a Euro grade diesel and what we use in Australia.
For the person who owns a common rail diesel engine, who really has to trust the expert's word, but is cautious about that, how are they going to know when they're, aside from the service book, but how are they in the seat of their pants going to know that they need to get their injectors serviced?
So there's two aspects. One, when the injector gets to a certain level of degradation, you're actually going to, or your mechanic will actually be able to see it on the scan tool and the live data coming out of the ECU. So as the injector wears, we start to see the injector behave differently. The ECU has a number of cover-up factors, if you like, where it will change and adjust what it does in order to cover up the problem.
Wow.
But as a mechanic, we get to see those on the live data that comes out of the ECU. So if your mechanic is smart enough and diligent enough to check, which is why you should always have a good diesel mechanic, it's quite important, that you will actually start to see this issue long before you may even feel it.
So we could trend that every 50,000 Ks, for example?
If for vehicles that we service here, we do it every single service.
Really?
It literally takes a few minutes to check, and it's something that is absolutely worth checking.
Wow, that is really cool.
Absolutely. Now, the other part is too, as the injector is starting to wear and we start to see these seizure-related things, basically we're having an issue with friction, where if we think about a good clean surface, they move nice and freely against each other. When they start to get torn up, like we start to see with these surfaces, they're actually creating variations in friction, and that the injector becomes slow and lazy, for want of a better term. The bigger issue is that it becomes inconsistent shot to shot, and that generally manifests itself in an engine that's a bit rough.
Okay.
Yeah, it's a bit one of those intangible things that's a bit hard to describe, but when you sit in a car that's got new injectors or a car that's got an old one, you can definitely pick which is the new or which one's the old.
So essentially the injector that's worn out is going to take that beautiful new engine refinement that's going to have been lost. It's going to be a little bit more tractor-like.
Exactly. Tractoring.
Tractoring, there you go. So hopefully that's been some really helpful information to give you the confidence in getting your injectors serviced on time so that you can have your common rail diesel running as it should be. He's a Matt and I'm a Matt. I'm MadMatt. Stay safe on the trails.